Chapter 5, Center of Gravity. Center of Gravity. It is a point where the whole weight of the body is assumed to act. That is, it is the point where entire distribution of gravitational force weight is supposed to be concentrated. Center of gravity is usually denoted by G for all 3D rigid bodies, example sphere, table, vehicle, dam, human, etc. Note: only समझने के लिए सिर्फ every body consists of particles. These particles are attracted towards the center of Earth. The force with which each particle of the body is attracted towards the center of Earth is called the weight of that particle. All these weights form a system of parallel forces acting towards the center of the Earth, which is far away from the body. Centroid. Centroid is the point where the whole area of a plane lamina figure is assumed to act. It is the point where the entire length, area, and volume is supposed to be concentrated. In other words, centroid is the geometrical center of a figure. Centroid term is used for two-dimensional figures, that is, areas. Example: rectangle, triangle, circle, semicircle, sector, etc. Center of mass. It is the point where the entire distribution of mass is supposed to be concentrated. Note: at surface of Earth, center of mass and center of gravity are considered to be same. It will slightly differ if body is too large as compared to Earth, which is hypothetical. Center of gravity of a flat plate. Flat plate having a uniform thickness T. Plate can be divided into small elements having weights W1, W2, Wn. Coordinates of elements are denoted by x1, y1, x2, y2, xn, yn. Resultant of the elementary forces is the total weight W of the plate. W, where it equals to W1 plus W2 plus plus Wn. W acts through point G having coordinates x bar, y bar, taking moment about y-axis and applying Varignon's theorem. W into x bar is equals to W1 x1 plus W2 x2 plus plus Wn xn. X bar is equals to W1 x1 plus W2 x2 plus plus Wn xn divided by W1 plus W2 plus plus Wn. Centroid of an area. Let T be the uniform thickness, rho be the mass density, and A be the total surface area of the plate. We know W is equals to m into G, where m is equals to V into rho. W becomes V rho G is equals to AT rho G. Similarly, considering the small elements of the plate, we get W1 is equals to A1T rho G, W2 is equals to A2T rho G, Wn is equals to ANT rho G, X bar is equals to A1T rho G into X1 plus A2T rho G into X2 plus plus ANT rho G Xn divided by A1T rho G plus A2T rho G plus plus ANT rho G. X bar is equals to A1 x1 plus A2 x2 plus plus AN xn divided by A1 plus A2 plus plus AN is equals to summation AI xi divided by summation AI. Similarly, taking moment about x-axis and applying Varignon's theorem, we get y bar is equals to A1 y1 plus A2 y2 plus plus AN yn divided by A1 plus A2 plus plus AN is equals to summation AI yi divided by summation AI. Mathematically, the above two expressions can also be represented as follows: x bar is equals to integration x dA divided by integration dA. Y bar is equals to integration y dA divided by integration dA. Note: points to remember. Centroid is the geometrical center of a figure. For a symmetric figure, centroid lies on the axis of symmetry. If the figure is symmetric about x then y coordinate of center of gravity, that is y bar, is equals to 0. If the figure is symmetric about y axis, then x coordinate of center of gravity, that is x bar, is equals to 0. If a figure has more than one axis of symmetry, then the intersection of axis of symmetry is the centroid of the given figure. Centroid may or may not lie on the given figure. If the axis of symmetry is inclined at 45 degree to horizontal line, then x bar is equals to y bar. Center of gravity of a thin bent bar wire. Thin wire can be divided into small elementary segments having weights W1, W2, W3, Wn. In this figure, thin bent wire having a uniform cross section. Coordinates of elements are denoted by x1, y1, x2, y2, x3, y3, xn, yn. Resultant of the elementary forces is the total weight W of the thin wire. W is equals to W1 plus W2 plus plus Wn. जो W है वो एक्ट करता है थ्रू पॉइंट G हैविंग कोऑर्डिनेट्स x bar, y bar. Taking moment about y axis and applying Varignon's theorem, we have x bar is equals to W1 x1 plus W2 x2 plus plus Wn xn divided by W1 plus W2 plus plus Wn. Let A be the cross-sectional area, rho be the mass density, and L total length of the thin wire. We know W is equals to mg, m is equals to v into rho, which becomes v rho g is equals to L into A into rho g. Similarly, considering the small elements of thin wire, we get W1 is equals to L1A rho g, W2 is equals to L2A rho g, Wn is equals to Lna rho g. Putting values in above relation, we get x bar is equals to L1A rho g into x1 plus L2A rho g into x2 plus plus Lna rho g into xn divided by L1A rho g plus L2A rho g plus plus Lna rho g. X bar is equals to L1 x1 plus L2 x2 plus plus Ln xn divided by L1 plus L2 plus plus Ln is equals to summation Li xi divided by summation Li. Similarly, taking moment about x-axis and applying Varignon's theorem, we get y bar is equals to L1 y1 plus L2 y2 plus plus Ln yn divided by L1 plus L2 plus plus Ln is equals to summation Li yi divided by summation Li. Mathematically, the above two expressions can also be represented as follows: x bar is equals to integral x dl divided by integral dl, y bar is equals to integration y dl divided by integration dl. Freely suspended plain lamina or bent wire in equilibrium. For a freely suspended plain lamina or a bent wire in equilibrium, the centroid or center of gravity will lie vertically below the point of suspension. If a plain lamina or a bent wire is freely suspended exactly through the centroid or center of gravity point, it will remain in equilibrium in any position. Centroid of areas. Centroid of